Now let's look at what's going on at substations in particular, and what is all that stuff. Remember that we generate the power at the power plant, we step it up and we transmit that power over the lines, then we come back to a substation and step it down and send it into our buildings. So the substation has an important role in this whole power transmission system. It does two primary things. You can see there's a lot of parts in here and it does other things, but the primary role is twofold. One, it has step-down transformers, that's these big green boxes here, that step down the voltage so you can send it over the wires to your buildings. And the other thing is that it gives you a place to disconnect the power if you need to. There are great big switches in here. It's common for substations to, as part of that grid, to come in and out of use as the load gets balanced. So you can send power through this substation. If you need to, easy to send it through a different substation using that grid. I just stuck these in because they're interesting for scale. This is a substation that EWeb used to have on Franklin Boulevard. It's been discontinued now, but you can see the sizes of some of the stuff. In a substation, power gets distributed over these bus bars. And you have bus bars in your electrical panel in your house too. It's just at the substation, these are bigger. And you will notice they come in sets of 3 because we have 3-phase power. And then redundancy is an important strategy to have, so you'll see a lot of redundancy in substations. There'll be at least 2 sets of buses, and that means if one of them goes down or there's some kind of failure, then the other one can come online. The biggest device at a substation is a transformer. It's this great big thing here. And when you walk past a substation and you hear this humming noise, that's the windings inside there flexing back and forth, back and forth. These are oil cooled, by the way. So you'll notice big oil tanks. How a transformer works is through induction. And you remember that when we looked at generators work through induction or inductance. Basic idea is, here's a diagram of a transformer. You got wires wrapped in a coil on one side, and current going through those wires makes a magnetic field, and that induces voltage and thus current in the other side. And the thing is, if you have more winds of wire on one side than you do on the other side, you can step down the power. So if you have twice as many windings on the incoming side, on the outgoing side you will have half the voltage. They're simple, elegant devices. And this on the lower right is a schematic symbol of a transformer. As you wander around looking at substations, you'll notice a couple of different ways to do them. This is a pretty small, simple substation in South Eugene, and you can see it has 3 transformers, each one for a single phase. They're smaller, so they're easy to move in and out, and if you have to repair them, you only have to take out one phase to repair it. This one, also in South Eugene, is a single 3-phase transformer. So needless to say, they're more cost-effective and more efficient, and you have less heat loss. Sticking out of the top of those transformers are these things called bushings. And this is a transformer at Celilo Celilo Falls used to be up on the Columbia River. And you notice that the bushings on one side are bigger than the bushings on the other side. What that is telling you is that this must be a step up or step down transformer because you have more voltage on one side than the other. These are bushings. These are just sitting in a rack. They're not in use right now. So they let current go through the inside of them, but they act as sort of insulators on the outside, and you'll notice that the big ones have oil in them for cooling. The other main device at a substation, besides the transformer, is the switch, the place where you can turn it on and off. And these are very similar to switches and circuit breakers in your electrical panel in your house. They're just big. If you see a box with two things coming out of the top, two bushings, you are looking at a switch. If you see a big box, like look down here in the lower left picture, it's a little bit small, but here are some transformers. If you see two things coming out of the top, that's a switch. And that can function either as a manual switch, you can go and turn it on or off, or it can function as a circuit breaker, just like in your house. Then there are things called capacitors, and a capacitor is a storage device. We will see capacitors in tiny electronic circuits in circuit boards later in the term. Here are big ones at a substation. And then distribution. So, as we've talked about before, these wires carry the electricity from the substation out to the house. And here are some more pictures again. Let's look at the drawing in our worksheet for assignment 5. There are a couple of questions about substations at the beginning, and then we have this schematic diagram of a substation. This happens to be out of our book. So this is what a drawing, a schematic of a substation might look like. And it's got a lot of squiggly lines on it, but if you slow down and begin to look at some of them, you notice here is a thing that is labeled transformer, and it is telling you what voltage it goes from or to. And notice you might say, oh, that's a really low voltage. No, it's not, because notice the K in there. These are kilovolts, so these are 1,000 volts. So here's a big transformer. Then this thing down here in the lower left is the standard symbol for a switch, and we'll see variations of this as we go along. Here in the bottom, you see some main switches. So there's just a line that represents the contact. That contact can touch that bar can touch the contacts or come open, and then here they're labeled with what capacity are they. Going along with this assignment is a handout. I have it on 2 slides here because it's big. So this is out of our book, and he is showing us the symbols that you use in a substation or power distribution schematic. Here are some switches and fuses and disconnects. Here are some transformer kinds of things and some couplings. And then here are various kinds of relays and connections.